what I've done is I ground the burr off of the blank, and I put it into the chuck, not too far in so that I can't actually get my tool in there and machine it, and not hanging out so far in space that any kind of pressure that I'm going to put on this end is going to cause it to wobble. Now, it's sort of, somewhere on here I have about the zen of machining. Somewhere, under mindset. So, the main thing that I found really surprising as I got into machining and everything is that people assumed that it was this highly rigid, highly controlled. It's like, ooh, this is a big, scary machine, and everything's super precise. And so, but there's actually, you really have to listen to everything that's happening with your machine and your material. So it's just the same with any other sort of tool process where, you know, you're filing and the metal is vibrating too much because it's too thin or it's hanging out in space too much or anything like that. That kind of common sense skill that we develop about really kind of listening to the tools and materials and having them tell us what's going right and what's going wrong. So it's the same thing with this. Now it's a little trickier because you haven't done this before, so it's like, how do I know if something's right or how do I know if something's wrong? But that's kind of where I have on here about the zen of machining, that you really just need to kind of think logically and don't forget everything else that you know. You know, it's like if you have like a long piece of metal and you try and like saw or cut like out here and it's unsupported, it's, you know, it's going to shake and vibrate and it sounds horrible and things like that. So it's the same kind of way here, where if you have the material too far out in space or you're trying to apply too much force to it, same kind of thing, is that it's going to wobble or possibly bend and things like that. So I went off script and I'm skipping ahead here, but we talked about materials a little bit. Generally, people don't machine silver and gold, although a lot of people do machine their waxes. Safety, just like we were talking out there with the bench grinder. All rotating processes share similar risks of projectiles or tangles, which is a nice, delicate way of, tangles are very bad. But it's the same kind of things that you want to think about with all that you learned about the polishing machines apply right here. So having anything long tied back, no dangling jewelry, all those kind of things. But it's, so you should feel relatively comfortable that you've dealt with rotating machinery before. The important thing with your setup, now I like my apron or coverall because you are going to be using a little bit of oil to improve cutting, just like you use wax with cutting your metal and things like that. So it is spinning, so it is going to spray a little bit on you. So just like with polishing, you might want to have a little work apron. Resist the temptation to touch any rotating parts until they come to a complete stop. Everyone laughs, but you all know you want to do that when you're like waiting for the polishing machine to turn, like slow down so you can change the buff or something like that. So let this just turn itself off. Now, just so you know, language-wise, in the machining world, just like all like plumbing and electrical and everything else, you have these subsets of vocabularies. So in machining, if you ever want to go and have something machined or something like that, everybody speaks in thousandths of an inch, and they don't reduce fractions. And it has to do with kind of implying how precise you're being. So if you talk about, well, you know, I want this machine down to 1/8 of an inch, generally then it's like plus or minus like 1/16 of an inch. So that's a very, very imprecise way of dealing with machining. So just so you know, everybody in machining land talks about thousandths of an inch. So 1/8 is 125 thousandths. And they never reduce fractions. It's not like you go into hundredths or anything else. Everything is thousandths. So it's like 10 thousandths or 100 thousandths or 125 thousandths or 50 thousandths or 500 thousandths or something like that. So it's just FYI if you ever want to like have something sent out and be machined and everything else. So don't rush. There's, you know, you have plenty of time to work on this stuff. We have a sign-up list right here. I did all these calendars for the 3 main processes you're getting into, so you can reserve your time, so there's not somebody standing over your shoulder like, hurry up, come on, I gotta get to my class, you know. So you don't want to be rushing with this. What I've said is, please do not sign up for more than 4 hours at a time outside of class, or for more than 30 minutes during class time. But you're welcome to do that. You want to make sure that you get in this particular class session on the lathe, and you want to work from 8:30 to 9, First come, first serve on here. Just sign on up. Now, I didn't black out when the other classes are. So obviously, since this is in the main room here, you can't be machining while someone else's class is right in here. It would be at the discretion of other instructors, like if you're doing electroforming or metal spinning, it would be at the discretion of those other instructors. I know some instructors just do not like any people extra in the studio because we already are filled to the max. And I know, for example, don't blame or hate Deanna, but she will be a total cop about it and likes nobody in the studio when her class is running. Just letting you know. That's how are you? Well, you're not in this studio this semester, but
if they ask and they're in the back, I don't care.
yeah. So everybody has slightly different policies, but just letting you know that right now. So how are you with metals? Like, you know, you're teaching metals 1 this semester, and it's like you want like, you know, 3 more people messing around electroforming, and you're trying to cast, and you know, it's just craziness in metals 1. So it's completely understandable that any of the metal 1 instructors just like a blanket policy. No.
I have 19 students in my class.
And they have no idea what they're doing yet.
No idea what they're doing.
Yes. So
Yes.
yes, they're working on it. So just keep that in mind. Signing up here does not guarantee that you can just waltz right in the middle of metals 1 and start machining. So I don't want to get calls. So talked about this end of machining. Process, use appropriate lubricant, match to the type of material being cut. Generally, just like the oil that we have here will be just fine. Okay, so your 0 point is where your cuttings will just graze the surface. So what I'm going to do is I'll set that up. We'll get our tool.
Does that tool have a name that's specific?
There's like different rakes and all kinds of things that I wasn't going to get into and confuse people. So yes, they all have particular names and they all have very particular functions. This is technically for threading. This is shaped to the triangle that goes in on, like if you took a microscope to threads that are cut around, it's actually like a triangular groove that's down in there, and that's what threading is and everything. Yeah, so this is like, you know, a screw cutting or threading tool or something like that. But this will be just fine for you guys. But there's all different kinds of different types of tools, different types of tool bits, different types of inserts. This is actually a carbide that's been soldered onto just a basic tool. Again, I didn't want give you too much information and have your guys' heads explode because it'll be messy. So what I want to do is not have my tool hanging out super far in space, but probably about 1 inch out, because what you have to do is we have to get this to there. So you want to make sure that that's out enough. So, and I tighten that down, and importantly, remove the chuck key. See, if you guys laugh, you might actually remember. The other thing people will forget is you want to put your tool, tighten your tool down. So everything is tight in here. So I forgot to grab my Allen wrench, which is going to be right here where Allen wrenches are supposed to be. And we're so happy about that. So these are just tightened down with an Allen wrench. So you want to make sure that's held securely there with your 3 set screws.
Now, is there a particular direction it goes in?
Lefty, loosey, righty, tighty.
The tool.
Oh, the tool? For right now, what I have is the point just pointing towards the material where we're going to be cutting. So,
okay, so
this is going to be spinning this way.
Yeah.
The tool surface is the top surface that you're cutting with, is going to be at the midpoint of your material. Now, the nice thing about these tools and this tool rest is it's automatically at the right height. So you don't have to worry about the height. But this top surface of this tool will be at the midline of your material that you're cutting.
Which way is that facing? Of the triangle, is that pointing up or down right now?
Oh, I see what you're
where's
saying.
the bevel?
Ah, good point. So it's like this, not like that.
Oh, okay.
Like this
Flat
is
side
up.
up. Flat
Yes.
side up. Got it.
The insert, the carbide insert is up. Not like that. Yeah, it's like some of those things I sort of forget because it's so ingrained in me. I'm like, why would you ever do that? That's craziness.
That's all the stuff Gary didn't tell me.
Yes, right, because it's, yeah.